Hello everyone, my name is Nikola Rankov and I work as a researcher at University of Bath. I will be presenting a talk called Simulation of Transionospheric Propagation over Yacamarca, Peru. This talk will show the initial development of a single propagation model experiencing equatorial scintillation. The equatorial ionosphere can have significant effect on radio propagation due to its complex behavior. Disturbances such as the equatorial anomaly and rising ionospheric plasma bubbles can significantly change the ionospheric conditions and thus distort the propagating signal. One such severe distortion is ionospheric scintillation. Scintillation is the random amplitude and phase fluctuations of a radio signal driven by rapid changes in the refractive index of the ionosphere. These sub-kilometer irregularities can cause refraction and diffraction of the incident radio waves, disrupting systems in RF communications, remote sensing, and navigation. In order to keep these systems operational, such irregularities have to be accurately modeled. This research tries to answer a simple question. Can a reliable model be built that will be able to simulate the changes to a RF signal propagating through an ionospheric irregularity? Any such model will require two parts, a model of the irregularity itself and a model of the propagation. The development stage of the model will address GNSS satellite-to-ground propagation transmitting on the L1 frequency band over the Yacamarca region in Peru. The accuracy of the model will then be evaluated using real data from the scintillation receivers from the Yacamarca Observatory. The diagram seen on this slide shows the workflow of the simulation during the development stage. The core of the simulation is achieved by implementing phase screen theory with a 2D split-step algorithm. The irregularity is simulated according to the power law spectrum models that have been documented extensively in previous research. Real DTEC data from GPS satellites and scintillation receivers in Yacamarca will be assimilated into the irregularity model. Calibration will then be achieved by comparing the amplitude scintillation index S4, calculated at the end of the simulation, with real S4 values obtained from the receivers in Yacamarca. The main motivation behind this research is to develop and calibrate a transionospheric propagation model that will be able to predict the behavior of radio signals operating on different frequency bands, used in various communication systems at low latitudes. Developing reliable and transferable models that can be implemented universally in different ionospheric conditions and in different communication systems is still a difficult task. Thank you for your time.